Hi, this is Randall Schwartz, host of FLOSS Weekly. This week, Jonathan Bennett joins me. We're going to be talking about PyRx. No, not the glassware, the kind of way you can figure out what drugs you need to make. You're not going to want to miss this, so stay tuned.
Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for FLOSS Weekly is provided by CacheFly at CACHEFLY.com.
This is FLOSS Weekly with Randall Schwartz and Jonathan Bennett, episode 464 for December 20th, 2017, PyRx. This episode of FLOSS Weekly is brought to you by GoToWebinar, a trusted webinar platform with over 55,000 customers who have hosted over 2.7 million interactive web events to connect with their audiences. For more, visit gotowebinar.com/podcast. And by Rocket Mortgage by Quicken Loans. Home plays a big role in your life. That's why Quicken Loans created Rocket Mortgage. It lets you apply simply and understand the entire mortgage process fully, so you can be confident that you're getting the right mortgage for you. Get started at rocketmortgage.com/floss. It's time for FLOSS Weekly, the show about free, libre, open source software. I'm your host, Randall Schwartz, Merlin at Stuntage.com, bringing you each week the movers, the shakers, the big projects, the little projects you may be using every day and unaware of it, projects you might want to download after the show and play with. Today is probably going to be one of those. Joining me again this week, I can't even use English today, Jonathan Bennett, welcome back to the show.
Hey, Randall, it's great to be here once again.
Once again. That's what I was trying to get to, once again. But I just said once. That didn't make any sense at all. So if you're watching the video, you can see that I have this very boring, plain wall behind me. That means I am in Beaverton, Oregon, home again after a 2-week trip down to Southern California. And Jonathan, I presume you're in your normal place, right?
I am. I'm here in the home office, the corporate headquarters in Lawton, Oklahoma. So everybody be sure to wave as you fly over.
Yes. I'll be doing that, I think, in about 4 weeks. I'll be actually crossing the country from the end of a cruise that ends up in Fort Lauderdale, heading back to Portland. So I don't know exactly what route it's taking, although I'm sure there's some website that would tell me exactly where it's going, but I don't remember right now, just off the top of my head. Anyway, so this week, our project is PyRx. I think I'm pronouncing that right, because that's how he pronounces it in his video. And by he, I mean the project coordinator leader is Sarkis Dallakian. I should have asked him how to pronounce his name a few minutes ago. I hope that was close. We'll find out in a minute if it was correct. Anyway, so PyRx is a virtual screening software for computational drug discovery that can be used to screen libraries of compounds against potential drug targets. I think if anybody's playing Buzzword Bingo this week, I think we already won. I think that's pretty much it. So I don't know much about this, except it's written in Python. It does drug discovery, whatever that is. I'm sure our guest will be a lot clearer about that. Jonathan, you want to help me out here? Or
Sure.
Or I stumble a bit more. Okay.
Not that I'm a drug researcher at all, but I did take a few minutes and take a look at this project, and apparently what it does is it simulates how different molecules of drugs fit together and whether they're going to have a chemical reaction as a result of that, which is apparently a very processor intensive function. And from what I was reading and listening to, they found a way to make that much quicker doing it with open source. It kind of reminds me of the Folding at Home project, just because it's kind of sort of in the same realm of the research they're doing. I don't know yet whether that's actually related or not. Maybe we'll have to ask him about it.
I was just going to bring that up because I remember that for a while I was actually running. I did both the SETI, the search for extraterrestrial stuff. I did SETI at home for a while, and then I also did Folding at home for a while. But I had my PlayStation just running constantly, so it was running those two applications. So it may or may not be related, but we'll find out in a few minutes because we're going to be bringing our guest on. But right before that, I do have an important message, because this episode of FLOSS Weekly is brought to you by GoToWebinar, the webinar platform that's hosted 2.7 million interactive web events with over 60 million views per year. GoToWebinar believes webinars are one of the best ways to interact with your prospects and customers instead of business presentations or company websites. With GoToWebinar, you can create custom email invitations, confirmations, and reminders, or let GoToWebinar handle it with automated email templates. You can display your company logo and custom image on all the webinar materials. You can create and schedule pre-recorded webinars that are as interactive as live events. It's mobile friendly. Schedule a webinar, edit a session, or track performance from your iOS or Android device. You can create up to 20 polls before the session or on the fly for audience interaction. You can add up to 20 questions to a survey and engage participants with Q&A. You can engage your audience in more than one presenter and panelist. Up to 6 presenters can share their webcams and participate face-to-face. You can broadcast a view of your desktop or specific application. And with GoToWebinar's reporting and analytics, you're just a click away from qualified leads, metrics, and data to improve webinars. You'll have end-to-end 128-bit AES encryption. It's rated number 1 customer satisfaction. So turn your next presentation into a conversation with GoToWebinar. For more information, visit gotowebinar.com/podcast. That's gotowebinar.com/podcast. And we thank GoToWebinar for their support of Floss Weekly. Let's go ahead and bring on our guest, Sarkis Dallakian. How close did I get on that?
Good, pretty good. Thank you very much.
Okay, awesome. So give us the 30,000-foot view. When people are reaching for PyRx, what problem are they trying to solve?
Yes, they are trying to find a molecule that will be a potential drug candidate, and they do that by screening libraries of compound against potential drug targets. The folding at home project is very, it's a first step to getting to that drug target. And I've started this project back in 2009 while I was working at the Scripps Research Institute. I was a lead developer for a program called Python Molecular Viewer. And we also around there, I was working at Art Olson Lab, which is called Molecular Graphics Lab. And we around there also a project called Fight AIDS at Home, which is similar to folding at home. There they all were also using IBM's resources, the whole community grade, to screen these compounds against different proteins.
So is this thing actually simulating what's happening in 3D space based on the shapes of the molecules?
Yes, it tries to, if you have a folded structure of the protein, it tries to find small molecules that will bind in different pockets and try to inhibit or somehow affect the biology.
So this is the kind of thing we can do on a home PC rather than, was this all the realm of supercomputers 20 years ago?
Yes, actually, when I started it, there were some script that you can use on a supercomputer, but there was no graphical user interface for this open source molecular drug docking program, which is called Autodoc. That was one of the first open source software available out there that can do protein ligand docking. Okay,
and when I looked at the website for this, I see that, yes, you claim this is open source, but I don't see an open source current version.
Yes, I've started it back in 2009. I have the version 0.8 as open source, and everything was the installers and everything was free. Currently, the source code is free. It's still hosted on SourceForge, but the building of the installers is, I do work on that, so I'm expecting to get paid for that. So I do this mostly as a hobby project.
Okay, and so, but you also base it on a number of open source technologies. Some of those are clearly GPL. So, are you complying with the GPL license if you keep some of it closed source?
Yes, it's like a Red Hat model. Everything built with the open source, but the final product is you pay to enjoy it. You can build it yourself, but it's time consuming. So to get the final product, to install the packages and all the dependencies and things like that, you will need to buy the paid version.
Okay, and how does I'm still sort of confused. And who's reaching for this? Who wants to use this?
Yeah, that's a good question. Initially, when I started this project, I was thinking there will be a few big pharma companies who will be interested in this, but after 4 or 5 years, I realized that most of the consumers are academics doing research.
And so this would be like somebody who's doing wants to make a drug to cure cancer, or I don't know, make you sneeze less or something. I mean, this is the kind of thing somebody would reach for to use that.
Right. If you are a medicinal chemist, you want to find a compound that will cure disease or fight viruses or whatever. This is a kind of program you can use for that.
So where does the raw data come from? I mean, clearly you have some information about like what, say, I'm making stuff up here because it's not my area, but like aspirin. Aspirin has a certain shape, right? And where does that data come from?
Yeah, so that data, the biology is like very old story. Like the data can come from the old herbal medicine or whatever, but the starting files for the PyRx are the PDB, which is Protein Data Bank, and it's basically three-dimensional structure of the protein molecule with XYZ coordinates and type of atoms in the molecule. And then you have libraries of compounds that you can get it, like aspirin, and you can see if you can use aspirin against other diseases and such.
So I wanted to jump in for just a second and ask about this. We mentioned folding at home, and then with Randall's question, it kind of folds into this. See what I did there?
Wow.
So does PyRx get fed then with folding at home data? Is that kind of how the data flow works?
Yes, it can be the starting point, but most of the time it's already something that is already folded, so to speak, and it's deposited in public protein data bank. And the structure that you get from there, it comes from X-ray or NMR or cryo-EM microscopy. The folding part is when you don't have the structure, you can't crystallize your molecule, or you don't know what the three-dimensional structure is. You have just the sequence and try to fold it and see what the three-dimensional structure of the protein is.
So we could say that there's several different techniques that have been established to take a compound and then get to this file that describes how it's folded and the details about it, and then we take that file type and we can feed it into PyRx and then manipulate it and research it from there?
Yes, right. It's basically tries to once you have your folded protein structure, you try to dock different compounds into that protein, see which one binds better. You basically have a list of the compounds and your folded structure, and you try to sort that list to find which one is the best candidate that will bind to that folded structure best.
And how much processing power and time does it take to run one of these simulations? Is this it completes in a few moments, or does it take days on a normal computer?
It's there are two programs that's like a docking engine. One is called Autodoc 4. The other one is called Autodoc Vina. The Autodoc 4 is CPU intensive. The Vina is also CPU intensive, but Vina runs way quicker. You will need like a couple of minutes to run a single docking of one protein against one target. But if you want to run like millions of compound, that will take like multiply that number by 1 million. But this can be done embarrassingly parallel way, so that you can, if you have a supercomputer with millions of cores, you can minimize that time.
So the project PyRx is not actually doing the simulation. Is it just the graphical front end then for the Autodoc programs?
Right. It's basically organized the files and lets you run this docking and get the results. It doesn't do the computation itself, but it's using the open source molecular docking programs to do that.
So it takes the, I assume, very complicated program to set up and use, and makes it more accessible by punching buttons instead of typing in what's probably almost source code to be able to get it to work. Is that the niche that PyRx fills?
Right. I was like a sysadmin, and I was in charge of the mailing list of Autodoc, and there are many people who would come and they will try to download and install it, especially on Windows, where you don't have any scripting experience or any scripting capabilities. they will try to run it and will run into all different kinds of problems. So PyRx tries to solve that problem and makes it very easy to do that.
Okay, so an interesting question that follows on is why Python? Why is PyRx a Python project?
Yeah, I've started, I've learned Python back in 2005 and never went back to C or other languages. I did some Perl, Java, or other languages, but Python is pretty amazing language. So I've been doing Python programming as like my day job, and all the infrastructure for preparing these molecules were written in Python. So it's a very nice language to use to do programming.
And so are there any notable discoveries that PyRx has been used in that you're at liberty to share?
Not that I know. I have the publication list on the website, on the main website. It's been used to do a lot of things, but I don't know any actual drug that was discovered with that. But it's been used. It's a long process. It takes 10 years to go from the structure into a clinical trial and do all this experiments. So yeah.
That would be a very interesting bit of, I guess, marketing information. If you could say that, well, such and such a successful drug was actually researched using PyRx, that would be an interesting tidbit to be able to give people.
Mm-hmm. Yeah, usually
Go ahead.
Yeah, usually these discoveries, when they are made, they are patented, and you can't go into details unless it's been done in academic center, like government-supported research. Like big pharma will never tell you what structure they use while they do that. It's a good thing for the doctors, to explain the patients how this drug works, if they can have all the so-called structure-based drug design information to the patient, but most of the time it's kept in secret.
So someone runs PyRx and they have their different possibilities programmed in, and it begins churning away. When it finds a match, does it light up and sound the klaxon and let you know that it's found something, or is it just a status report at the end? What does that look like?
Oh, that's a good question. Yeah, it just runs them, and in the end, it gives you the final result, which is a table of the ligand and the binding energy. So you can sort it and find the best candidate there. Yeah.
And so is PyRx run itself on some of these supercomputers, or does it just kind of set things up and feed them to it? How does it work on some of the bigger infrastructure like a supercomputer?
Yes, if you have a HPC cluster, you can submit the jobs to the cluster. But most of the time, most of the people who are using that, they are running it on Windows. So they will run it either on a local workstation, but it has an option to submit 2 jobs to the cluster. And I'm working on having an Amazon Web Services option, where if you don't have a local supercomputer available, you can submit it to Amazon and get the result. But currently it's it has 3 different options: Linux, Mac, and Windows. Most of the people who download and use it, they are using on Windows, and they are using their local resources. But the best way to run it's on a supercomputer with Linux, with the QSub job scheduler and things like that.
So you talked about local resources, how most people run it. Is that strictly CPU, or does and I assume it would be the underlying the Autodoc software, is there support for doing GPU-based simulations?
There have been some attempts. I haven't ventured into that yet. Yeah, I know GPU can dramatically speed up, but the VINA is fast enough, and there have been discussions on how to do that on the GPU. I know that there might be a couple of forks of the docking engine to run on GPU, but I haven't seen success stories it running 100 times faster, but that's something I'm considering as well.
So you talk a lot about what PyRx specifically is, but it's actually mostly just a graphical front end for other projects. Have you found and contributed to the other projects that are upstream from you?
Yes. I've been I've been working in the upstream projects like the Python molecular viewer. I've done some work on Autodoc, the engine itself. I've helped with the website and all the mailing list and things like that.
So other than you, how many other contributors actually contribute to the PyRx part itself?
Yeah, none. When I started, it's like I tried to get somebody involved, but there were a couple of people who are joining the project, but it's such a niche project there you can't find many developers. Many people who are interested in this, they are not developers, they are biochemists, so they have no programming experience. So it's only me working on that currently.
Yeah, we see that a lot with some, not a lot, but we see it some with some open source projects, that really the kind of people who are the typical end users are also typically not programmers. And so you end up with this very narrow cluster of people that are actually contributing to it. But, you've got a big microphone here right now. What kind of resources would you ask for if you could wish for anything?
I'm currently considering switching to subscription-based services. If there is any programmer who has experience converting the Python programs into subscription-based services, and then anyone who is interested in drug discovery, who has spare time or who wants to get paid for developing PyRx is welcome to join the project.
And so your particular contribution here is this graphic interface then. And if that wasn't there, what would people have to be using? Something that's like a text-based file or something?
Right. There are some scripting options available, but again, you need to be good at scripting to use that. And on Windows, the script won't work. So yeah.
Okay, and so what am I actually interacting with? I'm sure we could pull up the real thing and see it that way, but what am I interacting with? I must see some sort of selection of possible compounds and order to run them in if I have a priority for that. Describe the interface for us.
Yes, so the interface is you start with the protein structure. You get it from Folding at Home project or Protein Data Bank, which is most likely the source. And then you convert it to something with the extension PDB-QT that adds some additional information to the protein, like charges and torsional degrees of freedom. So you start with the input PDB file, you convert it to something suitable for Autodoc to use it for docking, and then you input the libraries of ligands. This can be from different sources. So basically you can have one of many proteins and one of many ligands, and then you go through the wizard, you select your protein, you select your ligand, and then you select the binding site where you think the ligands might bind to that particular protein, or you can do, which is something called blind docking, select the largest size possible to include the whole protein, and then you run it, which does a single molecule docking against protein, and then it loops through all the ligands and proteins, and in the end you get the final result, which is binding energy of the ligands against particular protein.
Do you have a sense right now of how many people are possibly running this at this very moment?
No, not at this very moment, but I've seen the stats on SourceForge. They're like 50,000 downloads, which is a big number for the scientific software. I have a number of customers that are around 200 that are paying for the software, so that's a good indicator.
Yeah, it's not a group of three. That's what I was hoping. It's not like three people running this. Do you have a sense of whether more people are running it just on their desktop PCs, or whether more of them are running it in the cloud with a big hardware?
I think most of them are Windows users, and they are running on a PC. I've seen users even high school students who download it and try to do big things. They run into the problems, but it's been used successfully to like run like 10,000 ligands against protein targets.
And what's important? And explain this in simple words, because I'm not a biologist or anything. But why do proteins have a shape, and why is it important to calculate that?
Yeah, that's a good question. I'm not a biologist either, but I've been reading biochemistry books. So there is like structure-function relationship. The way they structure dictate what functions they do. It's okay. One of the problem is it's not a single structure, but it's easier to interpret this with the computers and describe it to humans. They can have many multiple structures that they do to function, but it's easier when it's one, like a rigid structure, and you try to dock a single compound.
And these basically control like the mixing. I mean, ultimately this results in things like hormones and growth activity, things like that in our body. And so it's important to understand these so you can be able to generate arbitrary actions in the body.
Right. It's the biology to get to that. Like, for example, HIV protease is a protein inside HIV virus that cleaves the proteins to make the viral capsid. So if you understand the biology, what that molecule is, and you can find a potential inhibitors that will block that, then you can get to the drug candidate. But the biology coming to find which protein you want to inhibit, what you want to do that, it's a very complicated problem, and there are many unknowns there, and people are trying to find different potential targets.
And this may be a way whack out question, but I know most of this is because you're trying to solve a problem. You're trying to fix something that's broken. But is anybody looking at the activities of possibly making us superhuman doing this kind of stuff?
There are something like age-related. It's the aging itself or superhuman. It's not well understood in the biological sense itself, but there are some attempts at trying to find fountain of youth or something like that. But it's very speculative.
Cool. You know, Jonathan's itching to jump back in, but I have a very important announcement before we do that, because this episode of Floss Weekly is brought to you by Rocket Mortgage by Quicken Loans. The mortgage experience wasn't keeping up with the times. It was dated and needed a client-focused technological revolution. That's why Quicken Loans created Rocket Mortgage. Rocket Mortgage gives you the confidence you need when it comes to buying a home or refinancing your existing home loan. It's simple, allowing you to fully understand all the details and be confident you're getting the right mortgage for you. It's convenient. Their trusted partners allow you to share your financial information with Rocket Mortgage at the touch of a button. It's powerful, whether you're looking to buy your first home or your 10th. Rocket Mortgage is able to perform thousands of calculations in seconds. Based on your income, assets, and credit, Rocket Mortgage can analyze all of the home loan options for which you qualify and find the one that's just right for you. Rocket Mortgage by Quicken Loans. Apply simply, understand fully, and mortgage confidently. To get started, go to rocketmortgage.com/floss. That's rocketmortgage.com/FLOSS. Equal housing lender, licensed in all 50 states, NMLSconsumeraccess.org number 3030. And we thank Rocket Mortgage by Quicken Loans for their support of Floss Weekly. And Jonathan, you had a question?
Well, I was going to say first, Randall, I'm not so sure about this. It sounds like you're trying to discover the super soldier serum, and that's how we get Red Skull. I'm not comfortable with this.
I'm just asking because I don't know, and here's an expert to talk to. So why don't you talk to him for a bit and see what you want to get from him?
Sarkis, I did want to ask a few more technical questions, more about the programming. So it's Python based. You said you support Windows, Linux, and Mac, which I know is not necessarily an easy thing. Do you use one of the GUI libraries that's cross-platform to make that happen?
Right. Well, I'm using something called WX Python. There are the other well-used libraries, PyQt. The WX Python is not as sexy as PyQt version, but for the licensing version, when I started it, the WX Python was the only one with the BSD license. I think Qt, you needed to have a commercial license and then this open source license. And I wasn't sure if I want to go to commercial source and the like freeware version. So I went with the WX Python, which is pretty good library to use for developing the code. I use on top of that something called Entot traits, which lets you build these GUIs that are easier to build and more like programmer friendly, and it lets you use all the best practices without doing much sweating all the details of the coding.
Yeah, when I worked on a project that's supporting all three major desktops, I also used the WX widgets, not the Python version, but it's the same underlying library. And I've had good success with that, so I find that interesting that someone else shares that experience. Have you hit any unusual or difficult problems that you've had to solve, particularly in supporting the big three desktops?
Yeah, I had recently, like one of the customers who emailed me. They said they upgraded to Mac High Sierra or the latest version, and then it killed my program. And then I've been using this laptop to support all different versions. I have my Windows desktop that I have also like virtual machine that's running CentOS, so that supports both Windows and Linux. And for Mac, I bought this laptop, which is mid-2009, and I tried to upgrade it. And then High Sierra wasn't supporting it. You need to get at least late 2009 models to be able to upgrade it. So I went and I looked at that and I thought, oh boy, I need to buy a new Mac laptop. But then I realized what was the problem. I fixed it and I sent it back. They downloaded it. It's working. It's working good.
So just the normal, we could call it fragmentation of there's 3 or 4 versions of Windows and there's like 3 versions of Mac that people use out there. And then there's, 15 different distributions of Linux. Has that been the main problem then that you've run up against?
Right. I try to avoid the DLL house. The packaging of the software is as hard as writing the software. So I try to package everything nicely without dependencies, but they are always like this particular issue with the Mac High Sierra was because they dropped the support for Python 2.6 and they moved to Python 2.7, and I didn't know that there was a linker dependencies there. So I just tried to got rid of the dependencies, and it's working nice now.
Sure. So what license is PyRx available under?
It's BSD liberal license. That's the best license I could find. I've read I'm not a lawyer, but I went through listening all the advantages of disadvantages of various licenses. But I'm using BSD license, and one of the reasons was because it's very liberal. You can start with BSD and then go closed source, but it's open source now, and I haven't had any issues with the license.
Okay, and then do you use, just because I'm curious, do you use Git to keep track of your files and do your development?
No, I still use SVN. Just because of the timing. If it was recently, I would use GitHub, but I've been using SVN. I'm a single developer, so it doesn't make much sense to switch to Git. But I've been using Git for other projects, but SVN is working pretty good for the purposes.
And I suppose the fact that you're using SVN is why you're not moved over to GitHub, but still on SourceForge?
Right. It's also, I have the Joomla web hosting there. They let you do something that they introduce some restrictions. You can use their mail server and stuff. But the website itself is run on a Joomla, which is PHP MySQL thing that you can do with SourceForge. I don't know if you can do that with GitHub, but it's. I know all the cool kids are using GitHub nowadays, but SourceForge has been working good for me.
Well, therefore, I don't remember how long it was. It was a few months. SourceForge started doing some very shady things with a couple of the projects that they host. But from what I can tell, SourceForge has kind of cleaned their act back up, and they've stopped, as Google would say, they've stopped being evil, and they'll probably never be as popular again. But at least the feeling I've gotten is that they're trying to still be responsible. Have you run into any real problems with SourceForge?
I know they switched hands like at the SourceForge, like in the last 10 years, the Slashdot was bought them. Now they are like somebody who owns them is based on San Diego, and they try to clean up. I know they were like some popular software were ingested with adware or some additional thing that they downloaded, installed, and they find out that they were installing some other product, and there were too many accounts. And I know that there are many critics of SourceForge, but I like it. There've been like sometimes when it gets down, and then I think to move my project, like at least the web side to some other sites, but it's okay. I think the last time I checked, they had 99% uptime, so it's pretty good.
Yeah, Sarkis, let me ask you this: Are you a full-time developer on PyRx? Is this your day job?
No, it's my hobby. I'm thinking to, like, if I retire someday, it can become my day job, but for now, it's a hobby.
Do you make any money at it, or is it just a labor of love?
Yeah, I make pretty good. Like I've started it with the pricing of it was one of the difficult part. I've been watching like Business of Software webcast and all this stuff. Mm-hmm. The pricing model, I started with $75, then I went to $150. Now it's $300 for academic version, and there is a pro version, and then the enterprise version. It's making pretty good money to pay for my kids, like computer games and all this stuff. So it's been working well.
So, do you have a test suite for this? What do you do to test it?
Yes, I have a test suite. It's very minimal. Like I know, like I've been working in writing test suites, but there are different philosophies on writing a test suite, but I have a test suite with coverage. I have like a 60% covered, but writing the test suite, it takes the time away from writing the program. So I am doing tests before I make the release, but there are always like edge cases that no test can predict. But yeah.
What's a typical time cycle on this? I think you talked a little bit about this before, but I don't think I fully understand the answer. So if I want to look for, like I want to take this protein and whatever I want to mix with it and then run that, is that a minute or an hour or a day or a year?
Typically, it's a minute. Like I have a user who, like, if your small molecule is small, it's like a minute to 5 minutes, maximum 10. But I had a user requested to like kill the job if it takes more than an hour, and I realized the small molecule was too large. So if it's too large, it might take days, but typically it's minutes.
And the technology that's used to simulate this stuff in 3D, has that been slowly refined when errors were found?
That's a good question. One of the problems with this kind of technology is like there aren't like many negative results aren't published. So you go based on the positive results, and the theory behind it, it's very simplified so that you can run it on a computer in a reasonable time. You can go like more physics-based simulation, do quantum mechanics and stuff that might take hundreds of years to do. So it's the physics is very simplified just to get the answer. It's not always accurate, and I've seen like some customers they run this. Basically, you need to, and in the end up with a list of the ligands that you think are appropriately ranked. Like you try to score your ligands based on how much you think they are more likely to be to bind your protein, but it can be sometimes worse than random. So like you can like go base your assumption on randomly selecting, and you might end up getting a better result. but the technology is still evolving, and it's still the active area of research.
Well, that's actually a little bit disappointing. I would have thought that we'd had a little bit better handle on things now that we're, dozens of years into the computer age. But, it is what it is, I guess. So do you have a sense because you do have customers in pharma, right? So do you have a sense of how much the software they run is proprietary versus open source?
It's mostly in the pharma, it's proprietary, but they have open source as well. But I think the IT budget of the pharma is mostly security based, like to make sure that they all depends on the computers, but they try to use proprietary programs for some things, but they also use open source everywhere.
That's cool. It's good to see at least that, we're doing more than just, running games and stuff in the cloud. We're actually doing some real actual work with the open source software. I appreciate that when that happens. We're almost out of time. Is there anything we didn't ask you that you want to make sure our audience is aware of before we have to let you go?
No, thank you. You covered everything. With the Python programming language, I would like to add that it's very good in the sense that everything I try to put my mind, like with Java or C, by the time I try to get to the coding, all the difficulties are becoming so hindering that you can't code whatever you intended. So with Python, you will always, if you have that in your mind, you will be able to program it. Yeah.
Well, great. I am happy to hear that at least at one point in your career you used a little bit of Perl. So at least I'm sort of justified there. That's kind of nice. I always ask two questions at the end of the show, but I already know what the answer to one of them is. That's Python. Your favorite scripting language is clearly Python, correct?
Right. Perl is actively used in bioinformatics, but it's one of the problem I encountered. It's write once language, you write it, it does complicated regular expression, but next day you try to read it, and it's a mess.
All right, now I'm just biting my tongue right now so that I don't pile up on that one. I'm not going to say a word there. But I do have to ask the other question, which is, what is your favorite text editor? What do you spend all day editing with?
I'm using Eclipse, which is pretty nice graphical IDE, integrated developer environment. Otherwise, like with text editor, I use Nano, Gedit, or Notepad, WordPad, whatever works.
Cool. Well, hey, it's been a great pleasure having you on the show today and talking about this project. It's very fundamental for helping researchers everywhere to try to solve the problems. There we go. Oh, Randall, anybody's going to do this show, I guess. Okay, anyway, so I'm looking for your name. So Sarkis, thanks for being on the show.
Thank you very much.
Great. That was Sarkis Dallakian. I hope I get that right again. What do you think there, Jonathan?
Super interesting project. Very, very, very niche project.
I don't think we've had a more niche. Yeah, I don't think we've had a more niche project on this show at all. I think this is definitely going to be the narrowest one that we've had. I can think of a couple others, but they're like 5 or 6 years ago. But so I don't remember specifically what it was. But anyway, keep going.
That yes, this might take the cake. If not necessarily the most niche project, it is the most niche project that is the most removed from what you and I normally do.
That's true.
Because
That's true.
Medical research is definitely not in my wheelhouse. I don't think it is yours either.
Well, I'm a health nut now because of all the stuff I've been researching on for the last 6 years about my own personal health and how that led me to ketogenic diets and things like that. So I do read about 150 health blogs whenever they come up on my RSS feed. And so I did have a sense that, that's sort of why I got towards those questions near the end about pharma and actually what kinds of things happen there, because I know there's a lot of what happens is big pharma publishing only the studies that work, and that could lead to pharmacy bias, lead to doctor prescription bias, things like that. And I wasn't going to really go there with him because it was like it's just a big issue. It's an issue now, especially also in nutrition. Both nutrition and pharma, at least in the U.S., suffer from these biases that are built into the way people do research. So I'm kind of I like that he said sometimes picking things at random actually makes it better. I thought, well, that's kind of cool. So maybe these programs aren't needed at all. But anything else before I read out the upcoming list?
Yeah, I was going to riff off of that. He mentioned something about they have trouble with their, I think he was talking about their test suite. One of the things that gives them trouble is people will report successes, but people won't report when it breaks.
Right.
And I found that very interesting because it biases things in a certain direction, but it also makes it very, very difficult to improve the tool's reliability. And so just thinking about that, it seems like we need what has happened with computers and even to some extent hardware, the open source revolution that's happened there. It sounds like we need that in, well, scientific research generally, but medical research specifically, because, well, what we've seen with open source software is there's this huge advantage when you let your community kind of crowdsource your problems. Everything gets better. And it just imagine what medicine might look like if we tried to apply some of those principles to it, and the elimination of bias, but also this idea that all bugs are shallow given enough eyeballs. Some of the hard problems in medicine, some random guy might be able to look at and go, oh, well, have you tried this? And because he's so far out of the box, he comes up with the right answer. So if you give people the data, the opportunity, and the tools to be able to try, ridiculously crazy things, or, things that people that spend all day doing it wouldn't think of, I think you get some really unusual and surprising results out of it. I think we need that.
Yeah, you're making a great point here, because it seems to me that still pharma and nutrition and everything like that is still in the ages of where we were with computers in the 80s, where everybody was competing with everybody else. So proprietary software was the name of the game, and we still have proprietary formulas. That part of it also is that there's a lot of money at risk. When you come up with a new drug, you have to do years of trials, and if it fails, then you've wasted all that money, and you only have whatever the patent life is, 14 years, whatever, to get that money back. So I can see that thinking in that mode would lead to where we are today with current medicine and stuff like that. But you're right. I think we need to have the same sort of revolution where everybody can stand on everybody else's shoulders, which makes for a very weird looking pyramid, but everybody stand on everybody else's shoulders.
Turns into a mosh pit.
It's like, yeah, it's not going to work at all, is it? Anyway, well, we can stand there and work off each other. And I've got this piece of the puzzle. I've got this piece of the puzzle. Let's put those two pieces together, and maybe we can solve the issues. And what's funny also is I'm thinking, how many times has PyRx been pulled up to solve the exact same problem in different companies? And think of the wasted electronic energy there. And the wasted, CPU power, the wasted researcher time, when that could have all been done in a more cooperative way, in a public way, and not have to reproduce that. Like maybe what PyRx needs is a list of here's what I ran and here's what I came up with, as a public library, essentially. Wouldn't that be cool? What do you think?
That is definitely an interesting idea. I've seen some projects that have done similar things, where they have just a website that, when you run the software, there's an opt-in button that says, okay, go ahead and share this up to the public cloud, and it'll throw that data up there. And then, kind of an entire different part of the project is the ability to mine that and try to find interesting things. That would be a very interesting addition to the project and even the ecosystem of PyRx.
Yeah, I wonder, and that could even be a subscription service, so so he can make a little bit more money doing that. So I don't know. Well, we'll see. Lots of things are possible. It's software. What the hell? Everything's possible. Anyway, here's what's coming up. We only have a few people on the short list because I need to send out a whole bunch of emails today and tomorrow because we have a lot of open slots to fill. Next week is going to be the Open Mainframe Project, which is to increase collaboration across mainframe community for open source software. A lot of those guys are running Linux on their supercomputers, and they can talk about that, so it's going to be fun. Immediately following that, Aragon, Blockchains for Democracy. That's going to be fun. Process Maker, which is a workflow manager, and Scan Code, which literally scans code and detects licenses, copyrights, package manifests, and dependencies. So that's all going to be pretty cool. So we do have many, many more shows than those four, but none are scheduled yet. I've got a bunch of people looking at stuff. So you can go to the big spreadsheet at twit.tv/floss. That's the homepage for this show, and the big spreadsheet is linked from there. If you have any other suggestions, again, please tell the project leader or the community coordinator to email me and I'll put them on right away because we got plenty of open slots still. We live stream this show at 9:30 a.m. Pacific time on Wednesdays at live.twit.tv. We take a number of questions from the live chat room that's there. You can follow us on Floss Weekly at Google+, or at Floss Weekly on Twitter. You can follow me at Randall L. Schwartz on Google+, and at Merlin on Twitter. So I am told to read this by the Home Office. What are your favorite segments, shows, or moments on Twit this year? We're putting together our best of episodes and want your help. Head over to twit.tv/bestof, BESTOF, all one word. Fill out the form with whatever information you remember and be part of making these special shows that will air the week between Christmas and New Year's, which means I'm probably not going to read this more. I'll probably won't read this all next week. It'll be over. It'll be time. By the way, also, we had this wonderful one on about a month ago on my birthday show. And she was promoting these friendship bracelets that girls, teen and preteen girls, are actually programming in C++, which I think is pretty amazing. And they were having a buy one, get one free sale on Thanksgiving Day. So I bought a pair. And I just got them, so that's why they're not even out of the box yet. But I'm going to play with this and see if I can pair one of these with my laptop and make it blink pretty colors and stuff. I'm not too into the color thing, but I'll give it a try. It's got Bluetooth in it. It's got a little buzzer in it, and I'll play with them. I don't know. They'll probably end up on a shelf somewhere, and I won't play with them after that. But anyway, I'm going to start. We'll play with that. So anything you want to plug, Jonathan?
Sure. I'll talk a little bit about the project I'm working on. I had an interesting visit to a job site where 2 or 3 different remote IT people had to be able to log into their hardware, and we had a mess of it. And it really made me think about the need for better ways to do remote login for hardware, not stuff that runs Windows, but things that have a serial port. And so that is something that we at CypherDyne are looking at doing. And if any of our listeners are interested in that sort of solution, hit me up. You can hit me on Twitter at JP_Bennett or directly at jbennett@cypherdyne.com, and let me know about that, and we can talk about what we can do for you.
And I've just been reminded by somebody whispering in my ear that we do not have a show next week. It's the Christmas week that I was actually just referring to. So, no, we won't have a show next week. And I'm still have an open slot the week after that. So I'm getting a little nervous about that. But I am sending out a flurry of mails today and to try to rally up some people that have been in the queue for a while. So that'll be fun. Jonathan, thanks once again. And happy holidays to you and to everybody that you want to wish that to recursively. Okay, that doesn't even make sense. It's like standing on everybody on the shoulders again. Okay.
It's a Christmas mosh pit.
I think I better wrap this show before I get crazier. So, Jonathan, thanks once again, and we'll see you all again in 2 weeks on Floss Weekly.